Okay, now we have GrimoireLab, a Python toolset for software development analytics. Bigger.
Yeah, boss. Okay. Thank you very much. Good morning. I'm sorry I don't have music, but I have some nice charts, so I hope that also makes for the day. First of all, if you want, you can download the slides. They are in my Twitter stream, and you can also get them from speakerdeck.com/Vitergia. Maybe it's interesting because they have some links so that you can click on them and so on. Well, I'm Jesus Gonzalez Barahona, and I'm going to talk about GrimoireLab. GrimoireLab is a new tool set for doing software development analytics. The idea is to retrieve information from software development repositories and use that information to produce any kind of stuff that you may be interested in, from dashboards to reports to nice web pages where you can see what's happening in a project, for instance. Our approach is not to analyze source code, but to analyze processes and activity. That means that you can go to Git repositories or to Baxilla repositories or to IRC channels or to mailing lists or to Stack Overflow and get the information about what's happening there. So our main focus is to track where development is happening or where people are talking about software development and get that information and then do analytics on it. The main aim is to find ways to learn how open source software and software in general is being developed, and also to find ways to visualize that information and make it clear so that projects can be self-aware of what's happening with them. So the structure of the talk is going to be like this. So first of all, I'm going very briefly to give some context about myself and GrimoireLab. Then we are going to start looking at the software, and that will become practical, yes, to show some examples of how you can use Python to retrieve information from repositories and stuff like that. And well, at the end, there is something for you. Well, I've been researching on this topic in the university for some years, and at some point, me and some people in my research group decided to start a small company doing the same kind of stuff. It is the company that did the software that I am presenting today. The company is intended to use the software as a community project. Right now, most of the contributions come from the company itself. But anybody is welcome to come and join the development and, of course, join the decisions on it. The company is 100% free software, free open source software, both for the software we use and for the software we produce. And if you want to see what the GrimoireLab can do, go to cauldron.io. It's basically a web service where you can enter a GitHub organization, an owner, or an organization, and basically it does the analytics for that repository. It's going to pull everything in the Git repository and everything related to issues and pull requests. And in some time, produces a nice dashboard for you. You can also browse the dashboards already produced. All of that is done with free software, and let's say that the glue software is GrimoireLab. Of course, there are many other software behind it, but still, you can get an idea of what can you do, and at the same time, analyze your pet project. By the way, the Python organization in GitHub is analyzed, so you can look for it, and you can look at the dashboard and see how Python is being developed. The software doing the magic is GrimoireLab. We have a long history of using Python for going to look for information of software repositories. We started with Metrics Grimoire, like maybe 10 years ago. That was a set of tools for retrieving information from repositories and storing in SQL databases. And we were using that technology for research for many years. But at some point, when we started the company, we decided that it was time to learn from the past and restructure everything from scratch. And we decided to rewrite everything. And one of the things that we decided is to use only Python. We had some other things in the previous tool chain. And the second one was to try to make it, as much structure as possible, so that we could have very easily support for new dashboards, for new kinds of repositories, for instance, or for new kinds of panels in a dashboard, or for new kinds of studies, so that we have now a pluggable structure where it's very easy to provide support for new things. And that's GrimoireLab. So we started like 1 year ago, and in fact, this is the first time we are presenting it fully. GrimoireLab has a very simple, let's say, structure from the point of view of the data flow. Usually, the data flow starts in repositories, Git, GitHub, Mailman, whatever. And we have a tool called Perceval, which basically goes to repositories, extracts information, and uploads to Elasticsearch if you want, because Perceval is completely database agnostic. It only gets the data and produces a collection of JSON documents that you can upload anywhere you want. In our case, we have software for uploading it to Elasticsearch. Then, that's what we call the raw index. An index in Elasticsearch is kind of a database or something. So we have raw indexes which have exactly the same information that you have in the original data source, which means that if you need to query wherever, you don't need to go any longer to the original data source, you just can query Elasticsearch, which is, of course, much easier. Then for producing, let's say, added value indexes, we use GrimoireLab. GrimoireLab goes to the raw indexes and enriches the information. For instance, can do things like calculate how long did it take to close a ticket, or tries to find out whether a pull request is still open or not and calculate numbers based on that, and stuff like that. So with that information, we produce, again in Elasticsearch, new indexes that we call enriched indexes. And those indexes are designed for BSON with Kibana. Can also be queried with Python scripts, for instance, but you can visualize them with Kibana. Our version of Kibana is Kibir, but it's a soft fork of it, so it's very similar, and you can also use Kibana if you want. And Kibana is producing the dashboard, the front ends. But with the same information that we have in Elasticsearch for Kibana, you can also use scripts to retrieve it and do other nice things. Let's go now one by one. But before that, if you want, go to the webpage of GrimoireLab and you can get much more information, of course. But let's go one tool at a time. I already presented Perceval. Remember, going to repositories and retrieving information and producing JSON documents. Then we have, I already talked about GrimoireLab. Remember, taking raw indexes and also managing Perceval if needed and uploaded information. Then we have Arthur over there. Arthur is going to be released as a stable during the next weeks, but you can already play with it. And Arthur is for orchestrating retrieval. When you are retrieving data from thousands of repositories of different kinds, and you want to do that continuously because you want to have the information updated, it's a complex task. Arthur is going to help us with that. So basically uses Redis database to know what's happening and have a list of jobs being done and stuff like that. And it's very useful if you have to retrieve information in the large. So for you to have an idea of a scale, right now we're working with the Linux Foundation in getting information from like 10,000 Git repositories, for instance, and maintaining that information continuously updated. Kibir, I already commented, our soft fork from Kibana. It's the only thing that is not Python. And panels. Panels is the configuration for Kibir, in fact, which is how the information about the dashboards that we are using and the visualizations and all of that. And then we have Sorting Hat. Sorting Hat was developed several years ago, and the idea is to track identities. It can do things like merging similar email addresses for the same person, or tracking affiliations for people based on email addresses or on GitDM information, for instance, if that information is available. So the idea is to try to make a mapping from identities to real persons, and then, if that's important for the project, do a mapping of that person to organizations, to companies, wherever. So all of them, as I said, except for Kibir, are written in Python. And in fact, are Python modules that can be used directly from a Python script. This is the tutorial that we are preparing. You have the link down here. And it is for trying to use everything in the GrimoireLab toolset. It's still work in progress, but have a look at it, and that's where you can find some more details that I'm not going to have time now to talk about. let's be practical, as I said, and let's start with Perceval. Once again, Perceval gets information from repositories and produces JSON files. So let's look at how to do that. It's quite simple. It's Python 3, so you just get a Python 3 environment, you install with PyPy, and that's it. PyPy install Perceval, you have the latest version, and then you just run it. With Perceval, Perceval is basically a Python module, but it's also a script. So you can run the script right over there. And just to state in this example, I want to run it with the Git backend on that URL, which is a Git repository. In this case, it's the Git repository of Perceval itself. And then it starts just fetching everything. Of course, it clones the repository to get the information and then runs git log with all sorts of options and wherever, and starts producing JSON documents with the information in the repository. You can do exactly that for like 20 different data sources. And it's like that. So you don't need to fight anymore with the APIs of the different repositories and stuff. If you want to do the same stuff from Python, it's like this. So you can see how I'm just importing the corresponding module from Perceval. This is for GitHub, by the way, but it's basically the same thing. Then I define the repository I'm interested in, and you can see how I just instantiate a Python class, which is GitHub, with the corresponding information for the repository name, the owner, and the API token for GitHub. Of course, you need to get an API token, but you know that that's very easy from the GitHub user interface. And once that's done, you get a nice Python generator with all the items in the API. In this case, the API is for pull requests and issues, so you get a nice JSON document per each pull request and per issue. And that's it. So this is, for instance, very simple code to just discriminate which ones are pull requests and which one are issues, because in the data we retrieve, there is a field which states whether this is a pull request or not. So it's just a matter of doing that. But you have all the data available, and you can do anything you may want within that loop. So this is for Perceval. The next step is looking, oh, I forgot about this, sorry. This is the list of backends that are right now supported. It's very easy to write a backend, by the way. If you are interested, it's usually like between 100 and 200 of Python lines of code. Most of them are just copying from a similar API. So it's quite simple. You can do that and do that on yourself. Perceval has a pluggable structure where it's very easy to incorporate that, even if you don't want to contribute upstream. But of course, we are more than happy to get your contribution if you want, and you want to produce a new backend for something. For instance, I have a backend for GitLab, which is still not here, but it took me like, I don't know, 2 afternoons to write. The next component, GrimoireLab. As I said, GrimoireLab is basically taking charge of storing information in Elasticsearch, and it can also run Perceval to get information. So remember that Perceval was just producing JSON documents. In fact, it is producing Python dictionaries. And Perceval GrimoireLab can run Perceval, get those Python dictionaries, and upload them as raw indexes to Elasticsearch, and then use the same information to be enriched and produce the enriched indexes. That means that basically GrimoireLab can produce dashboards, because the information stored there is what Kibana uses to visualize. And this is the way for using GrimoireLab. So again, it's a Python module, so you can install with from PyPy. And you also have another one, which is GrimoireLab, which is a part of the same package, but it's different because the job of GrimoireLab is to upload the panels to Kibana, to Elasticsearch, so that they can be shown with Kibana. So remember that panels module that I was talking about, where we have definitions for visualizations and dashboards and stuff. The work of Kidash is basically uploading that information to Kibana so that you can produce automatically the dashboard. Of course, you can also do that via the Kibana user interface, but this is faster. So the tool for running this, once you install GrimoireLab, you have a module which is called GrimoireLab, and a tool which is P2O. P2O is basically getting information from the repositories and creating the raw and the enriched indexes. So that's everything. And it just, you just only need to specify the name of the indexes, git raw and git in this case. where the Elasticsearch instance is going to be. In this case, it was my laptop, so localhost. And you have to say, for instance, in this case, no inc means I don't want it to work incrementally. I want everything from the very beginning. And minus debug just to show some information about how it is working and where the repository is. In this case, it is a Git repository, and that's the list. And basically, that is going to do the same thing as before, as Perceval did, but storing the information in Elasticsearch. Once you do that, you can upload to Kibana the information about the dashboard and stuff, and that's it. You have 2 raw indexes, and you have a Kibana dashboard. You now point your web browser to Kibana, and there's the dashboard for this repository. You can do that for many repositories if you want, because the index can be reused and include information for many other repositories. And if you run again the same command without the no inc option, it's basically going to go incrementally over the data source. That's basically it's going to ask, please give me everything since the last time I got this information. So it's very efficient, and it can be ran every, for instance, 10 minutes, and we very much synchronize it with, I don't know, a GitHub project, for instance. So I already talked about Perceval, GrimoireLab, but well, when you are using Python, you can also use information in the Elasticsearch, because in many cases you are not exactly interested in producing a dashboard. You want to get some specific information that you may want, or maybe you want to visualize it somewhere in some other way. So basically, you want to access the Elasticsearch information and do wherever you may want with it. This is not something that we did, but I'm going to explain it so that you can see the value of having access to the data from Python. So for this, we are using the standard Elasticsearch API. The Elasticsearch API is a nice REST API, basically where you can query using HTTP on the REST, on the API. So this is using curl for just getting one element of the index. And you can have an idea of what you have in the index. Of course, this is a JSON document, and basically you have, for instance, information, basic information in this case, for a commit. In the real thing, you have like 30 different parameters, obtained from the commit, and then also adapted and enriched with GrimoireLab. But you get the idea. So this is what you get with curl. If you want to do similar stuff with Python, it's a matter of using specific Elasticsearch packages that are going to access Elasticsearch in a nicer way. So the people from Elasticsearch are producing 2 packages for Python, Elasticsearch and Elasticsearch DSL. Elasticsearch is like the low-level one, basically mimics the API, and it's quite simple to use if you know the API, but a bit difficult if you want to do complex queries. So that's why they also have Elasticsearch DSL, and the idea of Elasticsearch DSL is quite similar to the idea of SQL Alchemy, if you know it. So the idea is to write composable queries so that making a query is just calling to some different functions on the same object, one after the other, so that you can compose very complex queries in a simple way. So in this case, we are at the first line, we are creating an Elasticsearch instance for Python, which is where my Elasticsearch lives. Then I create a search, a basic search, just saying I want to search something on the index, and the index is Git in this case. And then I start adding parameters to the query. So begin with, I say, I want files created at 0. That means that for each commit, we keep track of how many files are touched by it, and we don't want commits that are not touching any files. Usually they are merged commits, and for this we don't need them. Then we say, I want everything where the author date is greater than 2016 and something. So that means give me all the data from that date on. Then I say I want commits with cardinality using the field has. That basically means give me unique commits. So if the same commit is repeated in several repositories, have the same hash, just give me one, count it as one. And then do a date histogram, which is basically using buckets as quarters, in this case, over time. So we are going to get several groups, each of them calculated and aggregated according to this. So in short, it's going to give me the count of commits by quarter, ignoring merged commits, and since some date. And for running it, you only execute it, and you get a Python generator where you can, and you get, in this case, a Python generator for each quarter, and basically you can print the information you may want. So you can see it's quite simple and quite easy as well. Just starting to finish, this is, as I said, the tutorial. If you look at the structure of the tutorial, there is support for Perceval, which is the more complete, and it's very easy to follow. Then there is some hints on how to produce dashboards, which is not much more than I told here. We are improving that part. And then there is a part about Python scripting. Probably during the next few weeks, I'm going to write something about how to combine this with pandas for doing, let's say, advanced analysis and stuff like that. But you can imagine that it's not that difficult. And again, remember, if you want to see everything working, you can just use the Cauldron IO. And there you can get an idea of what can be produced with the software. And remember, there are many dashboards, even if you don't want to produce your own, there are many dashboards already produced that you can check, including the Python one, well, the Python according to the Python organization in GitHub. And yes, to finish, so enjoy. And remember that we have the main webpage for the project here. We welcome contributions, and we are trying to create a community. And this is the right moment for entering it, because this is the first, let's say, public announcement to developers. We have been talking about this for 2 other people for a while. But if you want to write a backend, or you have any idea about a new kind of analysis, or you just want to use it but don't figure out how to do that, please let us know. We are more than happy of supporting you. Thank you very much. Okay, we have some time for questions or comments, if you have any. Yes, please.
Thank you for the talk. So, is Perceval provides any API, HTTP API?
Sorry, can you repeat?
Is Perceval provides any HTTP API? Like, I want to build like a chatbot or something.
No, Perceval is quite simple. It only provides JSON documents. In fact, as you saw, what it provides is a Python generator, and it's in its round of the Python generator, and you get a Python dictionary. With that, you can do anything you may want. But right now, we have no support for anything else except for uploading to Elasticsearch, as I commented. Any other comment or question or whatever? Okay. Thank you very much.
Thank you a lot.